Welcome to class today, pre-calculus students. On this Tuesday morning, hope you guys are doing well. Hope you're working hard, and please call me or email me if you have any questions at all. Do not hesitate to do that. I'm getting paid to teach you guys, and I want you to feel free to contact me whenever you need to. Here's some quick announcements, so please listen carefully. This coming Monday, in about 6 days, you'll be at my house unless you choose not to. By the way, if you ever choose not to come, I would like to know no later than Sunday, just out of courtesy to me, if you would do that, please. But a test this Monday, I'll give you a review sheet on Friday, so make sure you're mentally ready for that. Number 2, keep up on your integrity sheets, check your answers, watch the help videos. I do not understand it when students do the homework and don't check their answers. You could do every single problem wrong, never know that you did it wrong, and then you would take the problems or you would solve the problems on the test and the quiz incorrectly. So please check your answers and watch the help videos if you need to. If you need to, contact me if you need to. Number 3, everyone has contacted me about their tests, so good job there. Quizzes were due yesterday. I do sometimes make these videos a couple of days early, and I'm doing that today. I'm actually making this video on Sunday, even though you're not listening to it until Tuesday. But quizzes were due yesterday on Monday. I need to hear from you if you've not contacted me, okay? And if everybody has, that would be great. There are the announcements. Please grab your notebooks, your pencils, your calculators, and books, and give me everything you got for the next 30, 40 minutes. And I will go as quickly as I can. If I go too fast, just pause the video, and hopefully we can cover some math today. We're going to look today at finding trig values of non-acute and or negative angles. Finding trig values of non-acute and or negative angles. Lesson 5.3, and the date today is the 17th if you like to keep track of that, the 17th. Now, listen, so far we have been finding the sine, cosine, tangent, cosecant, secant, and cotangent of acute angles. You might not have realized that, but that's the truth, okay? We have been finding the sine, cosine, and tangent, cosecant, secant, and cosecant of acute angles, and that's going to change today, all right? Now, the first thing you need to understand, and I'm not sure why it did that, so give me a second. I always try to fix this stuff whenever I can right away. There we go. The first thing that you need to understand, now listen to me, read along here as I read out loud, is that the sine, cosine, tangent, cosecant, secant, and cotangent, listen, of a non-acute angle is the same as the sine, cosine, tangent, cosecant, secant, and cotangent of its reference angle. Let me say that again. You need to understand that when I ask you to find the sine, the cosine, the tangent, the cosecant, secant, and cotangent of a non-acute angle, that means an angle 90 or bigger. When I ask you to do that, it's the exact same thing as finding the sine, cosine, tangent, cosecant, secant, and cotangent of its reference angle, with one exception. Sometimes the signs will change, positives and negatives, and we'll get into that a little later. Don't worry about that now. So here's the concept I want you to grasp right off the bat. Are you ready? If I ask you to find the sine of 150 degrees, now listen to me. We learned yesterday how to find the reference angle for 150. Remember? We start here and we go 90 and then 60 more, and then we draw our angle, and we learned yesterday the reference angle was always this angle that fell between the x-axis and the terminal side. So if I went 150 degrees, then the reference angle was 30 degrees, because 150 plus 30 would be 180 degrees. Now you see why you learned that, because today when I ask you to find the sine of 150, that's the exact same thing as finding the sine of its reference angle. And what's the reference angle of 150? 30 degrees. So we're going to apply that today. The only thing that changes is sometimes there's a change in the sign, a positive or a negative, and we'll get into that when we get into it. But understand, that's our goal today, and you need to realize that we're going to use the reference angles. Now, I'm going to fix this too while I can, so I do apologize. I'm not sure what happened, but every now and then, there we go. let me give you an example that will make the above comments make more sense. All right? Let me show you something here. Take some really good notes on this, please, okay? Let's see. With your calculator, I'm going to grab my calculator. I want you to go ahead and type in the sine of 180, 210 degrees. Would you please? Go ahead with your calculator and type in the sine of 210 degrees. And you should get negative 0.5. Do you see that okay? Now, would you watch this? Let's find the reference angle for 210 degrees. Watch what happens. Let's find the reference angle for 210 degrees. 180 and then 30 more. So there we go. Now the reference angle, as we know, is this little angle right here that falls between the x-axis and the terminal side. Now from here to here is 180, then 30 more degrees would give me 210. So the reference angle is 30 degrees. Now I want you to type into your calculator, now don't forget, what's the reference angle of 210? The reference angle of 210 is 30 degrees. Now I want you to type into your calculator the sine of 30 degrees. Go ahead and do that and see what you get out. If you type it in correctly, you will get out, oh, look at that, you get out 0.5. So do you see what I'm saying to you? When I ask you to find the sine of an angle that's 90 or larger, you can use the reference angle to help you find that answer. The only thing is, sometimes the signs change. And if you'll look at the next page here, we're going to talk about those signs in just a second, okay? But do you see how this works? Now you might say, well, Mr. Earhart, why are you boring us with this? I can just type it into my calculator. Not necessarily. Don't forget that sometimes I like you to use exact answers for these problems. For example, if I ask you to find the tangent of 300 degrees, go ahead and write that down, the tangent of 300. Instead of typing that into your calculator, I would like you to do this. Let's go around 300 degrees and stop right here, and we're left over with 60 for our reference angle. Remember, your reference angle is always the angle between the x-axis and the terminal side. So the reference angle for tangent of 300, the reference angle for 300 is 60. Well, guess what? Do you know what the tangent of 60 is? You should know. Remember our special triangles we used to draw up? 60 degrees, this is a 2, this is a 1, this is a square root of 3, right angle. The tangent of 60, opposite over adjacent, is square root of 3. Now think about that. Remember what I told you? When I'm asking you to find a trig function of an angle larger than 90, it's the same thing as the reference angle, except sometimes the signs change. Well, look at this. The tangent of 300, since the tangent of 60 is the square root of 3, the tangent of 300 would also be the square root of 3. Now, it is negative, and I'm going to teach you how to know the signs later, but my point is simply this. These reference angles are very, very important. They're going to help you find exact answers, okay? So with that in mind, let's go ahead and jump ahead and look at some signs, and we're going to tie all this together. Now, please write this in your notes. You need to know this. Let's go over the signs, over the different signs for the trig functions. Now, first of all, this is quadrant number 1. Don't forget that. This is quadrant number 2. Please don't forget that. This is quadrant number 3, and this is quadrant number 4. Now, when I say the sign sequence for quadrant 1 is positive, 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 that means sine, cosine, and tangent. And by the way, their inverse functions go along with them. So if sine is positive, then also cosecant is positive. If cosine is positive, then secant is positive. If tangent is positive, then cotangent is positive. Let's come over here. When I give you the sine sequence in the second quadrant, I'm going to explain all this to you later, don't worry. But when it says plus, minus, minus, that means sine, cosine, tangent. Sine, cosine, tangent. Positive, negative, negative. Now don't forget what goes along with sine, cosecant, what goes along with cosine, secant, and what goes along with tangent, cotangent. Okay, same thing down here. Let's get this out of the way. Negative, negative, positive, that would be sine, cosine, tangent. So in this quadrant, sine is negative, cosine is negative, tangent is positive. And don't forget what goes along with sine. Cosecant, cosine has secant tagging along, and tangent has cotangent tagging along. Then over here, negative, positive, negative. That simply means in the fourth quadrant, the sine would be negative, the cosine would be positive, and the tangent would be negative. And what goes along with sine? Well, cosecant. What goes along with cosine? Secant does. And what goes along with tangent? Cotangent does. Okay? So you need to know these. I'm not saying, well, no, actually you are going to have to memorize them. I mean, eventually you're going to have to know them. And they're really easy. Guys, as you look at this, I mean, we know the first quadrant's all positive. That's all your acute angles, less than 90. Well, look at the pattern here. Plus, minus, 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 plus. That's so easy. Plus, minus, 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 plus. Sine, cosine, tangent, sine, cosine, tangent. And then here, just remember that cosine in the fourth quadrant, cosine is the only one that's positive. And of course, what goes along with cosine is secant. So cosine and secant are the only ones that are positive in the fourth quadrant. Everything else is negative. It's that easy. So everything here is positive. Everything here is positive. Over here, it's plus, minus, 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 plus. And then here, the only thing that's positive is your cosine. So with that in mind, hopefully I've not totally lost you yet. With that in mind, let's go ahead and start working some problems now. And I'll go really slow. Well, kind of slow. And hopefully you'll get a hold of this okay. Now, I do not want you using calculators on these problems. I want exact answers. So if I want exact answers, I guess I better pause real quick and do something. In your notes, you take notes however you want to, but we are going to be doing these 6 problems down here. I better write my special triangles because I'm going to need them. So this is a right angle. We'll call this 45 degrees. This is a 1, and a square root of 2. And then over here, let's draw another right triangle like this. And this is my right angle. This will be my 60 down here. This will be my 30 up here. And this is my 2. This is my 1, square root of 3. Now, I have these memorized. You really need to get to the point where you can whip those out pretty quickly, guys. Really, you should, okay? All right. I want us to find the sine of 150, but I want you to use exact answers. Now, nowhere do I have 150 in my special triangles. So I come up here and I find the reference angle. Now, watch what I do. Please take some good notes. The reference angle for 150 is 30. And here's how I know that. I start here. I go 90 plus 60 more is 150. Draw my angle. So the leftover reference angle on the inside is 30. So watch what I do. Are you ready, guys? Watch. Instead of taking the sine of 50, I'm going to take the sine of 30. That's not bad. That's easy. So the reference angle for 150 is 30. Now hold it. You got to check your sine out. So it's what quadrant are we in right now? We're in the second quadrant. That's where your reference angle is. It's in the second quadrant. Sine, cosine, tangent. Sine, cosine, tangent. So in this quadrant, what is sine? It's positive. So I come down here and I put a positive sign out here so I don't forget my answer is going to be positive. Now, what is the sine of 30? Well, let's come over here and find it. Here's 30. Opposite over hypotenuse. Opposite over hypotenuse. So it's going to be 1/2. So the sine of 30 is 1/2. And don't forget there's a positive sign out front, so positive 1/2. So, what is the sine of 150 then? The sine of 150 is positive 1/2. Because remember, I can find the reference angle and find the sine of the reference angle and then check my sine, my positives and negatives, make sure it's accurate, and then I have the answer without even knowing what the sine of 150 was. I now found it without using a calculator. That's really, really cool. Now let's find the cosine of 225. The cosine of 225. So here we go. We don't have 225 on our triangle, so we're going to start here. We're going to go 90 and then 180 and then 45 more, and I'm going to stop. That's 225 degrees. So if I went 90 and 90 is 180 and then 45 more, that means this angle right here is 45 degrees. So now you see the reference angle is right here. Here's the reference angle. The reference angle is 45 degrees. So instead of writing the cosine of 225, I'm going to convert that to the cosine of 45 degrees, but hold it. I got to check my sine. Sine, cosine, tangent. Sine, cosine, tangent. Well, it looks like to me that cosine is negative in this quadrant. So be careful. Don't forget to tack on a negative sign out here. All right. Now, what is the cosine of 45 degrees? Let's come over here and find out. Here's 45 degrees. Adjacent over hypotenuse. Adjacent over hypotenuse. So 1 over square root of 2. But don't forget your negative sign. But then, of course, we don't want a radical in the denominator, so our final answer is negative square root of 2 over 2. There we go. So, what is the cosine of 225? Negative square root of 2 over 2. There we go. You did it. You found the cosine of 225 using exact numbers by using a reference angle. It's not that hard. If you'll just really, really pay attention and do what I tell you to do here, I think you'll be okay. All right, the tangent of negative 780. Negative 780. Now, it's really not that hard. I mean, it's negative, so we'll start here. We'll go around once. That's 360. Oh, by the way, notice I went down. It's a negative angle. So I started here. I didn't go up like that. I went down. So go around once. That's 360. Go around again. That's 720. So I have 60 left over. So I go 60 more degrees and draw my line. There we go. So think about it, guys. I went around once, 360. I went around again, 720, and then I went 60 more. So this little angle right here is 60 degrees. So the reference angle for 780 is 60 degrees. So now I'm going to write tangent of 60 degrees. But hold it. Check your sign. We're in the fourth quadrant. Sine, cosine, tangent. Sine, cosine, tangent. Looks like to me tangent is negative. Tangent is negative. So put a negative sign here so I don't forget. All right, now what is the tangent of 60? I don't know. Let's find out. Let's come over here. Here's 60 right here. Opposite over adjacent. Opposite over adjacent. Square root of 3 over 1. So square root of 3 over 1. Bring down your negative sign. So negative square root of 3. There we go. So the tangent of negative 780 is negative square root of 3. Really, really cool. You guys are doing some really tough stuff here. All right, cosecant of 300. Okay, we don't worry that it's cosecant. No big deal. We can handle that. First of all, 300 degrees. So we're going to start here and go 300, and we're left over with 60 degrees. We went 300 and stopped here, so the angle right here would be 60 degrees. There's my reference angle. So instead of finding the cosecant of 300, I'm going to find the cosecant of 60 degrees. Now, what is my sign for cosecant? Well, cosecant goes with sine. So here's sine right here, and sine's negative, so cosecant is also going to be negative. So negative. Now, do you remember the formula for cosecant? Now think about it. Sine is opposite over hypotenuse, and cosecant is the inverse of that. So cosecant is going to be hypotenuse over opposite. Okay? So here's 60. Hypotenuse is 2. Opposite is square root of 3. So I'm going to get 2 over square root of 3. Don't forget your negative sign. But then multiply the top and the bottom by the square root of 3, and you would get negative 2 square root of 3 all over 3. And there's your answer. This is so cool. So the cosecant of 300 degrees would be negative 2 square root of 3 all over 3. Really, really neat. All right, I'm going to clear this off to give me some space to work with. Secant of negative 300. Secant of negative 300. Well, let's see here. First of all, negative 300 would be starting here, going 300 and stopping right here with 60 degrees left over. So I went 300 and there's 60 left over. So the reference angle for negative 300 is 60. So I'm really finding the secant of 60. Now, notice in the first quadrant, everything's positive, so I don't have to worry about any negative signs. And now, what's the secant of 60? Well, think about it. I mean, secant is the inverse of cosine, and cosine is what? Adjacent over hypotenuse. So then secant has to be hypotenuse over adjacent. Hypotenuse over adjacent. So hypotenuse, here's 60. Hypotenuse 2, adjacent is 1. Hypotenuse is 2. Here's my angle, 60. Hypotenuse is 2, adjacent is 1. So hypotenuse over adjacent would be 2. So the secant of negative 300 degrees would be 2. So you're solving these without using a calculator, using exact numbers. To me, that's pretty cool. All right, cosine of 315, and we're done with this page. Move on to something else. Cosine of 315. Well, it's positive, so we'll go up and around 315. Let's stop. If I go 315 degrees, the only thing left here to give me 360 is 45 degrees. So the reference angle for 315 is 45. So instead of taking the cotangent of 315, I'm going to take the cotangent of 45. But hold it, let's check our sine. We're in the fourth quadrant. So sine, cosine, tangent, negative. And tangent and cotangent go together. So I know my answer is going to be negative. So negative cotangent of 45 degrees. Now what is the cotangent of 45 degrees? Well, hold it. We know tangent is opposite over adjacent, TOA. Well, cotangent is the inverse, so cotangent would have to be adjacent over opposite. So we're dealing with 45 degrees. Adjacent would be 1 right here. Opposite would be 1, so 1 over 1 is 1. So the answer is 1, but don't forget to bring down your negative sign, so negative 1. So the cotangent of 315 degrees is negative 1. We did a bunch of these. We just totally solved a bunch of trig functions on angles that were either negative or larger than 90 degrees. So really good job, pretty good stuff. Okay, let's move on and try some more difficult problems. Go ahead and copy this in your notes as I'm talking. What if I gave you a problem like this, and I said, okay, an angle starts here, and it circles around once, and circles around again, and stops right here. But notice I didn't give you any angles, so you really don't know what the reference angle is right here. You have no idea. But I did give you an ordered pair right here. I gave you this ordered pair that falls right on the terminal side right here, and the ordered pair is square root of 7, comma 3. Could you find all trig functions? Sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta? Maybe you could, maybe you couldn't. Let's find out. I want to show you something that's really, really cool. You don't always need the angle if you know an ordered pair that falls on the terminal side. Let me show you what I mean. I'm going to go ahead and draw a right angle in this quadrant number 4. See this? Take some good notes here. I'm going to go ahead and draw a right triangle. Notice, students, I went straight over on the x-axis and straight down. Okay? Now, there we go. Now, think about this for a second. This ordered pair, now watch this. This ordered pair right here is how far over square root of 7 and how far down. That should be a negative 3, so go ahead and fix that in your notes. Sorry about that, negative 3. It's over square root of 7, it's down negative 3. So now I know the length of this top line here has to be square root of 7, and I know the length of this line going down has to be 3, because I went over square root of 7 and down 3. So now I can pick this triangle up right here, and I can draw it like this over here. Wow, that's a really nice triangle, isn't it? It's worse yet. Now watch this. There's this angle, so I know I have square root of 7 here. I know I have 3 here. I know I have a right angle here. Remember we didn't know what this angle was right here? Remember? I put a question mark there. Well, let's call it theta. And now we can we not find the hypotenuse really quickly? Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared? Sure we can. 3 squared is 9. The square root of 7 squared is 7 equals, should be 8 squared, equals hypotenuse squared. So 16 equals hypotenuse squared. Take the square root of both sides, and 4 equals h. Very cool. Look at that, students. Now you know all 4 sides of the triangle, and you can definitely find the sine of theta. That was really a tough problem. I hope you got everything that I just did there. Notice again, I did not give you any angle references at all. all that I gave you was this ordered pair, and from that ordered pair you were able to realize how far over you were, how far down you were, label those two sides, draw the triangle off to the side, use Pythagorean Theorem, find the missing side, hypotenuse, and now we can find the rest of these very, very quickly. But hold it, I just had a thought. I don't have many of those, so we better take advantage of it. I'm in quadrant 4, right? What's the signs when you're in quadrant 4? Negative, positive, negative. So let's write those over here now. Sine's negative, and so is cosecant. Cosine is positive, so secant will be positive. Tangent's negative, and so cotangent will be negative. Always check your signs when you're not in quadrant 1. Okay, the sine of theta, opposite over hypotenuse, so 3/4. So then cosecant will be negative 4/3. Very good. Cosine of theta is adjacent over hypotenuse, so square root of 7/4. So secant would be 4 over square root of 7. Of course, that's not good enough, so we have to convert that to 4 square root of 7 all over 7, and it is positive. Tangent. Well, tangent is opposite over adjacent. Opposite over adjacent, 3 over square root of 7, so negative 3 over square root of 7. Of course, that's unacceptable, so our final answer would be negative 3 square root of 7 all over 7. And then down here for cotangent, we just take this right here, and we just simply flip it, so we'd have negative square root of 7 over 3. There we go. You did it. Without knowing this angle at all, you totally were able to find all 6 trig functions. All right, how about this one? Talk about a challenging problem. You guys will really be challenged on this one, so get ready to think really hard. Copy this problem down and go ahead and draw your coordinate plane. Hopefully yours will look a little better than mine. All right, now, all that we know is I have a terminal side that fits this linear equation. And I know I'm in quadrant 2, so I know it's going to shoot up. I know one thing for sure. I know that my ray is going to be in quadrant 2, so I'm going to go ahead and draw that like this. So I knew that for sure because it says I'm in quadrant 2. That's given to you. Now, man, guys, I am struggling here. I mean, I don't know a angle to use. I don't have a point. Like at least in the last problem, I had an ordered pair right here, right? Maybe I do have an ordered pair though. I just thought of something. This linear equation does come shooting out of here, and maybe I can put a number in for x and then get a y out. That might work. I'm going to go ahead and put a number in for x and then solve for y so I can get an ordered pair that lies on this linear equation, an x number and a y number, and then that'll be a point that falls on that terminal side. So I think I got this. All right, let's see. 4x plus y equals 0. I'm going to put 1 in for x. I'm just trying to pick an easy number. So 4, 1 plus y equals 0. 4 times 1 is 4 plus y equals 0. Bring the 4 over and make it a negative 4, and y equals negative 4. Now somewhere I have copied this wrong out of the book because actually I haven't. And I'll tell you what I did that was wrong. And I love making mistakes in front of you guys because it makes you feel more comfortable to make mistakes yourself. When I picked my x value, what number did I pick? I picked 1, didn't I? And that's not a bad idea, but look what quadrant I'm in. I'm over here, so my x values are over here. So I better pick a negative x value because I want to find an ordered pair that falls somewhere on this terminal side. And if I put 1 in, that means I'm over here somewhere, positive 1, and that's not going to help me. So I do apologize for that mistake, but that should make sense what I'm saying. I want to pick a negative number over here somewhere. So I'm going to try this again, and I'm going to use negative 1 for x instead of positive 1. And let's see if that makes a difference. 4 times negative 1 is negative 4. Now bring the negative 4 over and make it positive, and it becomes a positive 4. So there we go. So it looks like to me the ordered pair is negative 1 That's what I put in for x. And when I put -1 in for x, I got out 4. So -1, 4 looks to be an ordered pair that falls on this line. So -1, 4. So that means I can go ahead and do this. That means I can draw my triangle. So I go over 1. And then I go shooting up. At least I try to. I go shooting up 4 units. So over 1, going up 4. So now I'm going to pick this triangle up. I'm going to draw it off to the side over here like this. It really is hard to draw on a mimeopad, guys, so I joke a lot, but it's not easy. Now, here's my right angle. See my right angle right here? This is a 1, so I put a 1 here. This is a 4, so I put a 4 here. Using Pythagorean's theorem, I would get square root of 17. And there we go. Now I'm ready to find all of my trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. All right? So, by the way, where would theta be? Remember, theta is always the angle down here formed between the terminal side and the x-axis. So here's theta right here. So my angle's right here. I'm going to go really fast, okay? Sine of theta would be opposite over hypotenuse. Oh, we forgot our signs, didn't we? Sorry, guys, totally forgot. It's positive, negative, negative. So sine will be positive. And I'm going to go ahead and quickly move those up here out of the way. So this quadrant is positive, negative, negative. All right. So we have 4 over the square root of 17. So that means down here, cosecant, the inverse, would be square root of 17 over 4. Now I've got to rationalize this, so I would get 4 square root of 17 over 17. All right, now let's try cosine of theta. And don't forget, here's sine. Cosine's negative in this quadrant, so negative. And then cosine of theta would be adjacent over hypotenuse. So 1 over square root of 17. So that means secant, I'm going to flip that. Secant of theta would be negative square root of 17 over 1. So back up here, I've got to rationalize, so my final answer would be negative square root of 17 over 17. Now, let's go ahead and try tangent of theta. Tangent of theta would be opposite over adjacent, opposite over adjacent. Opposite over adjacent, 4 over 1. Notice sine, cosine, tangent. Tangent is negative in this quadrant. So it's going to be negative 4. And so cotangent, you're going to flip that, would be negative 1/4. That was really cool. So we started off with not knowing any angle, not knowing any ordered pair, and we took a linear equation and we found an ordered pair that works. Pretty good. Okay. I think we're just about done. Last problem, guys, so hang in there. Just about done. So tangent of angle B is 5, and that's in quadrant 3. That's all they're going to give you, and they want you to find the other trig functions. Now, this is not too bad. Watch carefully here. I know I'm in quadrant 3, so that's a little bit of a help. And I know what tangent of angle B is, so quadrant 3. So I don't know where I'm at in quadrant 3. I'm just going to draw a line out kind of like this. And I should have gone like this and this. I'm going to draw a line that's out kind of like that. And I'm going to switch colors. And here's my angle right here, my reference angle. So I know that I'm in quadrant 3, and I know my angle here is beta B. And I know tangent of B is what? Come on, guys. Opposite over adjacent, TOA. So this is my opposite side, and this is my adjacent side. So I know that for sure. I'm going to go ahead and draw a right angle. Or a right triangle. I'm going to come down here, come over here, come up like this, and now I'm going to fill things in. This is my right angle. This is the angle I'm dealing with. Now tangent is opposite over adjacent, so I'm going to go opposite. That's got to be a 5. Adjacent's got to be a 1, and look what I've done. This is so easy, guys. I realized I was in quadrant 3, so I drew my ray coming out in quadrant 3. Then I drew my triangle. Then I labeled the two sides that I knew, and now using Pythagorean's theorem, I would get the square root of 26 for the hypotenuse. So we're good to go. I mean, we are really, really, totally ready to go. I'm gonna get a little bit of space here. I'm going to go really fast and get this done so you can start your homework, okay? So the only thing is, don't forget your signs. It's negative, negative, positive. Okay, don't forget that. So sine of beta would be opposite over hypotenuse. Opposite over hypotenuse, but look, sine is negative, so I've got to put a negative sign. So it would be negative 5 over square root of 26. Then we're going to flip that for cosecant. So cosecant of beta would be negative square root of 26 over 5. Now up here we've got to finish this, so it would be negative 5 square root of 26 all over 26. And that's totally gone. Now let's take a look at cosine of beta. Cosine would be adjacent over hypotenuse. Adjacent over hypotenuse. So 1 over square root of 26. And by the way, what is cosine? It's negative in this quadrant. So don't forget your negative sign. So I'm going to go ahead and get secant real quick here while I'm on cosine. Secant would be negative square root of 26 over 1, or just square root of 26. Up here we've got to rationalize. So I would have a negative square root of 26 over 26. And cross that off. And now we're moving on. Tangent of B equals opposite over adjacent. Opposite over adjacent, 5. And by the way, tangent is positive in this quadrant, so we would just simply have 5. And so cotangent of beta would be 1/5. Flip your 5, 1/5. Look at that, we did it. This has not been easy, I know that, but it's so important. And we're not going that fast, guys. I mean, we've spent a couple of days now in 5.3. I'm trying to really make sure you guys get this stuff. Oh, a quick comment. Please, please don't miss this comment. This is really going to help you, okay? Remember the other day you did 41 through, I forget what it was, 60-something, and you just found the reference angles? Now you're going to do the whole thing. So when you get to 41 through 77, first of all, notice it's every other odd. So you would do 41, add 4, do 45, add 4, do 49, etc., all the way until you get to 77. Notice 25 through 37 is odd. So you'll do 25, 27, 29, all the way until you get to 37, okay? So please make sure you really, really work hard on these. Call me or email me if you have any questions. And when you get to this section here, 41 through 77, you now do everything the direction says and solve those completely, okay? Work hard, ask questions. If I can help you, don't hesitate to contact me.